Hello and welcome. Today we're going to talk about something really cool, a material that connects the fastest cars on Earth with the future of green energy. So let's dive right into the incredible world of composite materials and figure out how we classify them.
All right, let's kick things off with a little puzzle for you. Take a look at these two things, a Formula One car built for pure, blistering speed, and a massive wind turbine blade designed to slice through the air and generate power. On the surface, they couldn't be more different, right? But they share a fundamental secret. Any guesses what that might be?
You got it. They're both built from composite materials. It's this advanced stuff that's the secret sauce behind their amazing performance. Composites give them a combination of strength and lightness that you just can't get from traditional materials like steel or aluminum.
So that begs the question, what is a composite material, really? Well, the easiest way to think about it is like a recipe. You take a couple of key ingredients, you combine them in just the right way, and you end up creating something totally new, something way, way better than its individual parts.
Now for the more official definition. A composite is a material made from at least two different components that don't just melt and blend into each other. And here's the magic part. When you combine them, the final product has properties that neither of the starting materials had on their own. It is the ultimate example of teamwork in the world of material science.
Okay, let's break down that recipe. First up, we have our first key ingredient, the matrix. I want you to think of the matrix as the binder. It's basically the glue that holds our entire creation together.
So, the matrix is the stuff that completely surrounds all the other ingredients. This could be an epoxy, a polymer, a ceramic, even a metal. But its number one job is to act like a super strong adhesive, binding everything together into one solid, cohesive part.
But here's what's really cool. The matrix does way more than just hold things together. It actually locks the strong fibers into the exact position and orientation that engineers want them. It also acts like a protective shield, keeping those fibers safe from scratches or chemicals. And, this is critical, when you put pressure on the material, the matrix makes sure to spread that load evenly across all the fibers so they can all work together as a team.
All right, so if the matrix is our binder, then our second ingredient is the real star of the show when it comes to performance. Let's talk about the reinforcement. This is where all the muscle comes from.
The reinforcement is the part that does all the heavy lifting. It carries most of the load. So, if the matrix is the glue, the reinforcement is like the strong, stiff skeleton that's embedded inside of it. This is where that incredible high-performance nature of a composite really comes from.
And you've got a few different options for this skeleton. There's carbon fiber, which is famous for being super stiff and incredibly lightweight. That's the stuff in that F1 car. Then there's glass fiber, a real workhorse that's more cost-effective. You'll find it in everything from boats to those giant wind turbine blades. And then you have aramid fibers. You might know them by the brand name Kevlar, which are known for being unbelievably tough and impact resistant.
So, let's put it all together side by side. You've got the matrix acting as the protective binder, holding everything in place, and then you have the reinforcement, which is the strong performer carrying the load. It's this perfect partnership, this incredible synergy that makes composites so powerful. Neither one could do the job alone, but together they're unstoppable.
Okay, so we've got our ingredients, the matrix and the reinforcement. But, just like when you're baking a cake, the arrangement of those ingredients is just as important as what you use. And that brings us to something called the ply. You see, it's all about layering. We start with one single, super thin sheet of our reinforcement soaked in the matrix, and we call that a ply. Now the thing is, a single ply is usually only strong in the direction its fibers are pointing. So, to get around that, engineers stack multiple plies on top of each other, creating what we call a laminate. And here's the clever bit. They change the fiber direction in each layer. Maybe one goes at 0 degrees, the next at 45, the one after at 90, and by doing this, they build a final material that's incredibly strong in every direction.
So, why are we talking about all this? Why do we classify composites by their matrix and their reinforcement and their ply? Well, because this is where all the theory turns into reality. This is how we actually start building amazing things.
Just look at these real-world recipes. For a high-end bike frame, you'd combine a polymer matrix with carbon fiber reinforcement. Why? To get a super lightweight and stiff result. For a bulletproof vest, you might use that same polymer matrix, but you swap in those tough aramid fibers to get extreme impact resistance. And for something like a jet engine blade that has to survive insane temperatures, use a ceramic matrix with ceramic fibers. See? Different recipes for totally different jobs.
And that's really the most important thing to take away from this. Understanding the matrix, the reinforcement, and the ply structure gives engineers this incredibly powerful toolkit. They're not just picking a material off a shelf anymore. They are literally designing brand new materials from scratch, perfectly tailored for whatever job they need to do.
This level of customization is what makes composites so revolutionary. These aren't just materials that we find in nature, they are materials that we design and invent. And it really makes you wonder, with these basic building blocks and our own creativity, what on earth are we going to create next?